Composite figures are basically a combination of two or more geometric shapes together that we need to find the area of. Now, generally speaking, when you're out in the real world and you're trying to find areas of stuff, generally speaking, they're not just perfect things. Like if I was to try to find the area of this room, well, this room is not a rectangle, is it? Nope. There's a little part over there that we'd have to kind of subtract out because it's, it's not there. There's maybe a little part by the door that we'd have to subtract out, and who knows about this whole cabinet area or whatever else, we might have to subtract stuff out like that. Or sometimes when you're making a deck and you're trying to figure out like how much stuff to put on there, do you just buy like 10 cans and hopefully you can just take some back? Well, that's one method. Otherwise, you can kind of figure out the area. Most of your deck looks like a square, but then part of it, since it's L-shaped, is like another, maybe like a rectangle or something like that. And you basically just add the two together, the two areas, it's fine, okay? It happens naturally in a lot of different places, whether you're finding areas of rooms or anything like that. That's just the easiest way I think of, because I really like architecture. I think architecture is pretty cool, so that's one thing I studied. Well, this is what we're going to work on. We're going to work on basic things like this. And what our goal is really is to look at these shapes and be able to identify, hey, there's two different shapes here. Basically, what we're doing is we're going to get some sort of game plan that we're basically going to have, here's a square here, and here's like half of a circle, okay? So what I'm going to do is that the very first thing I'm going to do is I'm going to say the area is going to equal, and this is going to be whatever my game plan is, okay? My game plan is I need to find the area of a square. Maybe I should write it like this, area of a square plus the area of maybe like half of a circle, okay? So all I'm doing is I'm basically writing down some sort of game plan that I'm going to work with, okay? How do you find the area of a square? Yeah, that's right, it would be sides squared. How do you find the area of a circle? It would be pi r squared, so pi r squared. And this would be only half of it because we're only going to do half of a circle. Because that's how you find the area of a square. It's side squared. Nope, that's for a rectangle. Okay. So for us, how long is our side of our square? 6. So we'll do 6 squared. Let's see, we would need to figure out the radius over here. So what's the radius of our circle? That might be a little more complicated. The whole thing here is 6. Is that the radius or the diameter? Diameter. So how far is the radius? 3. So that'd be pi times 3 squared. Okay? Let's look at the directions to figure out how we're supposed to round this. It says find the area of each composite figure, show all your work, and circle your final answers. Round each to the nearest tenth if necessary. Am I going to use the pi button on my calculator? Yes, I am. Am I going to, let's see, am I going to calculate the pi? Yeah, you are. So with your calculators, everyone please put this in. I just want to make sure we all get the same answer. Okay, we're running the nearest tenth. Raise your hand when you have an answer. Running the nearest tenth. Raise your hand when you have an answer. Come on, come on. There's 3 people that have an answer. 4, 5, 6. 6 people have an answer. Maddie, what'd you get? Altogether. Holy Christmas cards. Sierra, what'd you get? Okay, then don't tell me. Hannah, what'd you get? 50.1 square feet. Okay, 50.1 square feet. All you're doing is you're doing 6 squared, which is 36, plus half of pi times 9. That's where we're at. Okay, so the idea is we get some sort of game plan to start off with. The area of a square plus the area of half a circle. And we basically just write out the formulas for each of those and calculate from there. The second one, what do we have in the second one?
Triangle.
Okay, so we basically have our area, our total area is going to equal the area of 1 square. I don't know why I keep writing that way. The area of a square plus twice the area of basically like a triangle, something like that. Okay, how do you find the area of a square? Okay, how do you find the area of a triangle? Okay, half times base times height. Okay, how long is the side for the square? How long is my base of my triangle? Be careful with this. This is the base. That's 8 as well. What's my height of my triangle then? It's 3. Okay. So a lot of this you can do in your head. 8 squared, 64. Twice of half is just 1. Then we just have 8 times 3 is 24. 24 plus 64 should be 88. So it should just be 88. Did everybody else get 88? Maybe I didn't give you time to think. Okay. Think fast. 88. And it does say, hey, run to the nearest tenth. If necessary, do we need to run to the nearest tenth there? Do we need to write 88.0? No, people think you're strange for putting zeros at the end. So that's it. Questions on how this works? Stop being strange. Okay. Number 3. Write down the game plan. Write down a game plan. You know, when you go into the Super Bowl, when you're leading the team, I guess there was a Super Bowl last night. The teams usually have some sort of game plan. Generally speaking, what they do is they map out their first 30 plays beforehand. They know what they're going to do their first 30 plays. And if they want, they can get off of that plan, but basically they'll have some sort of plan what they're going to run to begin with. And they might adjust it later on, but that's where they're at. They start off with a game plan. Hopefully your game plan for this looks something like this, that you'll find the area of some sort of rectangle, area of a rectangle plus the area of a triangle. Area of the rectangle is going to be base times height. The area of the triangle is going to be 1/2 base times height. Now, the base and the height here stand for the base and the height of the rectangle. So what's the base of the rectangle? 18. What's the height of the rectangle? 10, okay? Now, if you mix those up, if you said 10 times 18, that's fine too. That does work. Okay. 1/2 the base of the triangle. What's the base of the triangle? 10. Okay, you've got to be careful with this next one. What's the height of the triangle? 12. Okay. The entire length here is 30. But then from here over, this part's 18. So basically we take 30 minus 18. I would leave 12 as height. This is 12. The 13 is basically the side length, which is not the height of the triangle at all. It's basically the side or the slant height. Okay. This will give you 180 right here. This will give you half of 120, which would be 60. Using your calculators or whatever means you need to. Did everybody get 240 square meters?
Yep. Would the base be 10 and the 13 both sides of this triangle?
Yeah, if we were to set this triangle straight up like this, this is 10, this is 12, and this is 13. So what's the base of that triangle? 10. What's the height? 12. Okay. Everyone write down your game plan for number 4. I'm going to pick somebody at random to share their game plan with us. By the way, you guys might think about going to Joseph and the Amazing Technicolor Dreamcoat. It's February 10th, 11th, and 17th, 18th, and 19th. It's supposed to be a very amazing show. It is religious, but it's not. It's a lot of fun. Dancing, high energy, high jinks, song, dance, algebra. You're not in algebra.
Yeah.
Sam Kleinsetzer, what'd you get for number 4? What's your game plan? Okay. How do you find the area of a rectangle? Area of a trapezoid. Excellent. So for the rectangle, Sam, what's the base of the rectangle? Okay, base is 10. What's the height of the rectangle? Okay, and for this part, tell me the bases of the trapezoid. Yep, 20 is the bottom one, and 10 is the top one. And what's the height of just the trapezoid? That's right, because this is 6. The whole thing is 18, so that leaves this to be 12. So we'd be multiplying by 12 out here. You got to be kind of careful with these because sometimes they just give you the total heights of things, and you need to break that down. What's this piece? What's this piece? Okay? This looks kind of like a mess, so sometimes people break this up into just say that part. 60 is the area of the rectangle. In here, this is 30. Half of 30 is 15. 15 times 12 is, oh, some big number. Let's say 30 and 180. So again, it's 240. This one's going to be square centimeters. So is that really the same area? No, not even close. If I had a room this size full of pizzas or a room this size full of pizzas, if I really liked pizzas, I'd rather have that room over there. Yeah. Much bigger. Same number, but different number of pizzas. You're right. Unless they're really small pizzas and really big pizzas, then probably the same number. Okay, number 5. Number 5. Why don't you guys try number 5 on your own? Try number 5 on your own. See how you're trying number 5 on your own. Okay, so what I'm looking at is there's 2 separate half circles or 2 semicircles there. 2 semicircles, but they're the exact same size, right? So if you add 2 circles together, 2 half circles together, that's going to be 1 full circle. And if I add these then together with a rectangle, I should be somewhere around 128.6. I got to look for the units. These would be square millimeters. Okay. Again, so the tricky part is you do have 2 half circles. If you add 2 halves together, that's 1 whole circle. They are the same size. Make sure that they are the same size before you do that. Maybe another tricky part is to figure out what the radius of that circle is. Since this is 3 and this is 3, that makes a total of 6. 15 minus 6 does give you 9, so this radius, or the diameter there, is going to be 9. So the radius has to be half of that. I know that's a lot of just small pieces that you're trying to figure out as you go along. Yes, sir. Oh, man, it's going to be a huge mess. Yep, it does. You're right. I was thinking of something else. I don't know what I was thinking. Maybe 13. So I'd make that a 3. Awesome. Great. Thanks for pointing that out. Anything else? Anything else? Okay. Is this okay so far? We're doing okay? All of these, if you've noticed, we have one shape and we're going to add some other shape on top of it, right? Okay. So all of this is basically one big shape. Like these are basically like rooms. Like this is some room and like all of a sudden we add this little bubble on this side and a bubble on this side. Okay. I guess that's how it would work. Like if all of a sudden I knocked out this wall and put a bubble over there, and knocked out this wall into the hallway, built a bubble in there, that'd be basically what I have. They're both adding things on. The next ones are kind of like donuts, okay? And the idea with donuts is basically how it was explained to me like a long time ago. Basically, they have this big piece of dough and basically they cut out the middle. I don't know if that's accurate or not, but they basically have this big shape and they cut something out of the middle, right? Like they punch it out or punch it out, whatever they have to do to get that stuff out of the middle of the donut, right? I don't, yeah, I don't, and then they make donut holes, which I guess is how it works. Well, with these shapes, it's kind of the same deal, okay? There's basically going to be some big shape that's going to be on the outside, and you're going to subtract some sort of small shape from it. So just like a donut where you have some big circle, and you basically cut a circle out of the middle, that's what you end up with. So what we're really looking for is we're looking for the area of the shaded portion of each figure. Okay, so let's look at the middle one, number 7, because it actually is a donut. It's a really, really skinny donut. Like I wouldn't pay for this. This is ridiculous. Except that it's in meters, so it's huge. But here's the deal: you have a giant circle on the outside. So basically, we're going to deal with the big circle, and we're going to subtract the small circle from it, and that'll leave us whatever's around the outside. Okay, so there's this really big circle. Then all of a sudden, somebody came through and they cut out this whole white part here, and they left us with just whatever's left. So we'll just say this. Okay, the area of the big circle is going to be, again, pi r squared. This will be pi r squared. They're different radiuses, though. What's the radius of the big circle? Okay. Okay, so it looks to me like the diameter of the big circle, this whole thing right here, this whole thing would be 40. That's what it says on the outside. So it would have to be 20. So I'd say pi times 20 squared. Now what's the radius of the small circle? 16. Yeah, it tells us 16 right there. So that would be 16. Luckily for us, we know what our perfect squares are. This would be 400 pi minus 256 pi. So that leaves us with 144 pi. And when you multiply that out, because I think it's a good idea to multiply that out, you're going to be in the 300s. Ooh, maybe even 400s. Totally serial. 452.4 needs to be square meters, and that's a pretty big donut. I mean, seriously, if that had glaze on it, you could eat off of that for probably at least a week. Maybe just school week, like 5 days. You might be able to share that with one of your friends. Think if you'd have like a big glass of orange juice too that you could kind of. I feel I'm very tolerant of all beverages. I like Dr. Pepper floats. Yep. Yep, what I do is I basically add a whole bunch of ice cream, about 3/4 of a glass of ice cream, melt it just a little bit, like it's melty a little bit, and then I add just a little bit of Dr. Pepper in there. There needs to be just the right amount of ice cream to Dr. Pepper, generally speaking, more ice cream. And then I kind of mix it up until it's kind of a soup, but like a thick soup. Yeah, so it's amazing as opposed to mediocre. Number 6, you basically have the area of a rectangle. And what you're going to do is you're going to subtract the area of a triangle. The area of the rectangle will be 30 times 20. The area of the triangle would then be 1/2 of 30 times 20. So 30 times 20 is going to be 600. Half of 30 times 20 is 300. So you would have 300 square centimeters. I really hope that you guys can do this. It's the area of the big shape minus the area of the small shape. The big shape is a rectangle. The small shape, the white shape here, is going to be the triangle. Number 8 is usually a tricky one. A lot of people think it's tricky. What goes on with this is the big shape is what? It's an area of rectangle. Could be, yeah. Could be a square. That's fine. Isn't a square also a rectangle? Okay. And then we're going to subtract 2 circles. So base times height here, we'd basically end up with 40 squared minus 2 times pi. Let's see, what would our radius be? 10 squared. So that'd be 1600 minus, let's see, that's 100, that's 200 pi. Looks like we're at 971.7 square inches. I really hope that you guys can do this on your own, as opposed to just depending on me. Okay, tomorrow I'm not going to be here. I have a math competition that I have to take care of up in the lecture hall. I'll be in the building all day long tomorrow, but I'm really in charge of a math competition from approximately 6:45 until about 11:30. It's the American Mathematics Competition. It's a national competition for like usually juniors and seniors. I do pull out some freshmen and sophomores from some of the upper level classes. And they'll be competing tomorrow against students all over the United States. And there'll be like subsequent contests that I have to monitor if people do well. So I will be gone out of this class tomorrow. You'll have some sort of substitute. I have no idea who they're going to be. I do need you guys to be nice to them. You'll either do more of this composite figure stuff tomorrow, or I might have you do like Pythagorean theorem type stuff. I might have you do some sort of algebra review stuff like you did the other day that I was gone. I just wanted to let you know that I'm going to be gone, so if you need help with this, I can't help you in the morning. You'll have to get help somewhere else. Any other math teacher would be fine. I do not think so. Nope. In the past I have. I don't think I will tomorrow. Okay? So things to remember from this stuff for composite figures. Sometimes you're going to have to, when you find area of the shaded region, it's usually the big shape minus the small shape. But all the others are basically, you're adding on to things. So here's a rectangle plus 2 of these things. Here's a rectangle plus a triangle. Here's a rectangle plus a trapezoid. Here's a square plus half a circle. And I think it's a really good idea to always have that game plan in mind before you get started.